Yeah. So this is the beauty of another beauty of chemistry. So the 180 elements have been arranged in a beautiful manner. Even today, we find difficulty while organizing the place or separating the material that was originally placed. After usage, we find difficulty to arrange it in order. But these elements are arranged in a very beautiful manner based on the atomic number and some other characteristics behavior. So you can ask me why I should aware of this knowledge of chemistry and other elemental behavior. Because as I told you in the beginning, irrespective of the discipline, like medicine, engineering, chemistry, or arts discipline, whatever may be your domain, you must aware of such type of elements. At least these type of elements daily you are come acrossing. So therefore, you must aware of at least a few elemental characteristics. All right. So with this small introduction part, I just want to get into the topic. Normally, as a teacher, while we teaching the some concepts, we used to ask our students to align with STEM concepts of the particular topic, so that which will facilitate to understand the concept more in deep. So like whatever the topic you learn, you must aware what is the role of science, what is the chemistry part, what is the science part, what is the mathematical part, and what is the technological part, and what is the engineering part is present in the particular topic. So if you read it, if you understand the topic in such a manner, you won't forget the topic. So as I told you in the beginning, the chemistry play a very significant role in the daily life. Also, it play a very crucial role in the engineering domains also. So when you look at the role of chemistry in various engineering disciplines, especially chemical engineering, I don't see much difference between this chemistry and engineering, chemical engineering aspect, because almost 90% of the developments and the process and things that is happening in the chemical engineering, that is entirely based on the chemistry aspects. One among the important aspect is going to be a use of catalysis for the development of new materials. Because in fact, I just want to introduce few chemistry concepts with relevant to engineering aspects. And later on, I just want to incorporate my field of research in the presentation. And the first is going to be a few basic concepts, because I could see some students also present in the meeting. So I just want to introduce some basic things initially, then I just move on to my research topic. So the first one is going to be a role of catalysis. It play a very significant. We all know that what is the catalyst, what is the role of it. It play a very significant role in the chemical reactions. So it will help us to reduce the activation energy of the reactant, so that we can get material in very easily. So if you are at all not using any catalyst at all, then it will force you to spend much amount of energy. Also, it will gives you a lot of byproducts. So the byproducts may be in the form of unusable manner, or it may be throw it in the atmosphere, so which will cause a lot of environmental impacts. Especially what type of materials are normally used as a catalytic materials. So normally, when you do in a small chemical reaction, we use in a kind of transition elements, first and second transition elements as a catalytic material, like 3D and 4D elements, because these type of transition elements do have a lot of vacant orbitals, and it has the ability to either accept or donate that electron, and it can speed up the chemical reaction by altering it will alter the chemical reaction rate. And by chance, if you are not using a proper catalyst, or if you are carrying out the chemical reaction without any catalyst, now what happens, there are a lot of there is a chance for the formation of a lot of byproduct that may be unusable in manner. So how to solve such kind of problems? By chance, if you are getting more waste material as byproduct, so that has to be properly managed, or otherwise if you throw it in the atmosphere, it will create a lot of environmental problems. So in such case, what are the alternate, what we can do for that? So this is the another aspect, that is going to be green chemistry. In fact, this is one part of chemistry which help us to get kind of eco-friendly product development process. Now, what is my green chemistry? First of all, In fact, the green chemistry doesn't mean that we should use only the greener material or we should go with the greener approach. It's not a literal meaning. So the literal meaning is going to be the green chemistry tells about we need to develop a material or we need to develop the process, in the eco-friendly manner. Okay, so which involves minimum usage of chemicals, maximum efficiency, and minimum development of effluents or other waste materials. And also it should be very useful. The product must be very useful. So that is called green chemistry. And this green chemistry principles are also find useful in various chemical and chemical engineering approach. With the help of these 12 principles, we can achieve whatever thing you want. For example, minimum use of materials and prevention of pollution, use of safer chemicals and safer solvent, use of renewable materials, and reusability and reproductivity, and use of appropriate catalysts for the development of products, and various other optimization techniques. So when you adapt this kind of green chemistry principle for development of products, it will facilitate you get a newer material with high efficiency with minimum byproduct formations. Now, what are the advantages of such type of green chemistry principles? So when you look at this here, the advantages are given over here, like it is a kind of an eco-friendly one, a greener one, and it doesn't cause any type of much toxic pollutants, safer and non-toxic things. Because there are, in the case of industrial effluents, when you look at it, the effluents which are discharged from the industry, heavy metal industry, they used to discharge different pollutants like coloring matters and heavy metals. So the contamination or the addition of such type of materials into the environment, especially in the water body, they create a lot of problems. So when you align with this green chemistry principle, we can minimize the pollutant to maximum extent. So that is the thing I just want to convey. And also, it doesn't require any skilled persons or maximum labor. Very minimum labor is sufficient enough. So we can save money also. And another thing I just want to highlight is going to be the role of chemistry in the mechanical aspect. So similar to chemical engineering aspect, mechanical people also using a lot of chemistry principle. And one of the principle I just want to highlight is going to be a formation of an alloy. So during the fabrication of material, people used to select the appropriate elements for making a particular alloy. So alloys, we all know what is an alloy. It is a combination of two or more than two metals. And while you're fabricating an alloy, we have to be very careful how to choose the proper material for making the particular alloy and for particular application. Otherwise, it is going to be useless because the main purpose of making alloy is going to be to prevent corrosion. But if you choose the elements very close to each other in the galvanic series or electrochemical series, that itself will accelerate the corrosion behavior, and the entire concept is going to be waste one. So therefore, we need to be very careful by choosing a proper element and the elemental composition also. So the chemistry principle will help us to get how to frame a particular alloy for the particular designated application. Using like phase rules. The phase rule concept will help you to make proper alloy for various applications. And if you fail to achieve proper elemental composition for the particular application, the $1 billion thief phenomena is going to be the problem. So it is nothing but corrosion phenomena. In European region, the corrosion phenomena is otherwise called as $1 billion thief because every year huge economic loss, several $1 billion economic losses occurs because of corrosion in the machinery part. So therefore, so those people they are calling this one as a $1 billion thief, and this is normally happens due to improper selection of metals and improper maintenance. And in fact, by chance, if the corrosion occurs on the particular elements, we may use other chemistry concepts such as like organic coating, metallic coatings, and various corrosion control techniques also to minimize corrosion to some extent. And this is the thing I just want to address you, that is how to choose the proper elements for making a particular alloy. So for this, we have two concepts called the electrochemical series. The first one, which is placed in the left hand side, and another one is going to be a galvanic series. So these two sequences will help us to get will help us to know to what extent the the elements are reactive nature. The elements which are placed over here, So they are this is more reactive and this is less reactive. There are, in other words, I can say the metals which are having positive electron potential value, they will have very much reluctant to undergo reduction reaction, and the elements which are having very high negative reduction potential value, they are highly susceptible to oxidation process, or simply can easily undergo corrosion behavior. So therefore, if you want to choose a metal for making a particular, if you making an alloy, the metal has to be chosen from the proper position of this electrochemical series. And it also has some limitations because it failed to explain some concepts why there are certain metals found to have, for example, according to the electrochemical series, zinc and aluminum is having negative reduction potential value, but it will exhibit good corrosion resistance. But it is failed in this, the electrochemical series failed to explain the particular concept, and this was replaced by, it was rectified by, in fact, this galvanic series. So these two concepts will help us to get the proper approach how to choose the particular metal for corrosion minimization process. Right. With rest, in another aspect is going to be application of chemistry concepts in electrical and electronic sectors. So it has many applications. I have chosen only two things. One is for storage device application, and another is going to be a display device application. And the first one I just want to address you is going to be application of material for storage devices. This is the one of the need of the hour in the modern day life. We use a lot of fossil fuels, and especially during the transportation process, and it used to discharge enormous amount of toxic, or other oxides of carbon, nitrogen, and sulfur oxides. And the excessive addition of this carbon dioxide, sulfur oxides into the atmosphere create a lot of climate change induced problems like global warming, acid rain, or ozone layer depletion as well. In order to minimize this problem, now government, the best example is going to be our capital city issue. So we all know that Delhi is one of the most polluted city. Yeah, Delhi is one of the most polluted city. It is. Hello. Hello.
Sorry, sir.
Okay, okay. Shall I proceed?
Yes, sir. Yes, sir.
Okay, okay, fine. So in order to minimize such kind of pollution problem, now we are forced to shift to another transportation technique that is going to be e-vehicles. Even we could see a lot of e-vehicles in the roadsides even today, even now. And according to the government instruction, by 2030, maximum vehicles should be shifted to e-transportation mode. Now, have you thought about what is the kind of power source that is being used in the particular type of e-vehicle system? Yeah, yes, of course. This is going to be a lithium batteries. So lithium battery is the one which is used in the e-vehicles. Now, have you thought about what are the components of such kind of lithium battery? We use a lot of battery like primary battery, that is alkaline battery, lead acid battery that is used in the automobile sectors now for to operate the vehicles for the ignition purpose and operating other electronic gadgets. But this is another one, other class of secondary storage battery that is going to be a lithium battery. Now the components of this lithium battery is going to be there are variety of batteries or lithium based batteries are used for various applications like a mobile phone, for operating mobile phones, laptops, and now for e-vehicles. There are lithium ion and lithium sulfur based batteries are predominantly used for automobiles in e-vehicles as an alternate power source. And this is going to be the kind of chemical reaction that is going to be happen in the lithium battery during charging and discharging process. Predominantly when compared to other type of secondary storage devices, for example, lead acid battery. So if you use if you take lead acid battery, it is a kind of liquid based, that is aqueous sulfuric acid is used as an electrolyte. If you improperly handle it, there is a chance for leakage of the particular electrolyte that is a highly hazardous nature. But when you look at this one, this is the beauty of this lithium battery. It is made up of a kind of lithium based anodes and cathodes, and this is using a kind of solid based kind of electrolytes. So it will allow only the passage of lithium ion. It won't allow the passage of electrons. And this is what the lithium ions are getting migrated from one region to another region during charging and discharging process. So during this process, the electrons are getting expelled from this battery, and it is used for operating other external devices. And another one application of chemistry is going to be a display device application. When I was young, when we are young, about during 1980s, we used only CRT based display devices. But now we have a lot of improved form of display devices. One among the display devices is going to be a kind of OLED technique and a PLED. So what is the difference between this old one and the present one? That one was, it is occupying largest phases, and also it will consume a lot of energy. But the improved one is going to be so it will give more clarity, and conception is very, it used to consume very less amount of energy, and it can be foldable. Even you could see some foldable devices also. Now, what is the material which are available inside of that particular display device units? So when you take polymer based LED or organic OLED, that is OLEDs, organic LED or polymer based OLED, it is made up of a kind of conductive and emissive layer. Almost the concept is going to be remain same. In the case of LCD, the CRT was replaced by LCD, then LCD is replaced by this OLED concepts. This is similar to semiconductor devices. When p and n junction type of diodes are connected together, it used to emit energy. And here also, when the conductive and emissive layer is sandwiched between these two anodes and cathodes, it used to emit a kind of electrons and holes. And whenever it combines each other, it will emit the energy. So that is the basic operating principle of this OLED technique. And these are the kind of materials are normally used in the OLED. Like this is going to be the one used as a conductive polymer, polystyrene, polystyrene and polyaniline based materials are normally used as a conductive layer. These are some basic concepts I have correlated with basic engineering domains, and now I just want to highlight my research area and how I have developed this polymeric substance for various engineering applications. And as highlighted in the introduction part, Dr. Vishwanathan has mentioned that my area of specialization is super absorbent polymer and hydrogens. Now, what are they? How it behaves? The super absorbent polymers are a class of applied polymer. They are derived from acrylic water soluble monomers. They are chemically cross-linked, and it has the ability to absorb and retain several grams of water. A gram of polymer is sufficient enough to hold more than 2 to 3 kilograms of water. And also it used to absorb variety of metal ions and dye materials when it is introduced in the effluents. So this applied polymer used for various biomedical applications also, that is going to be in a hydrogen. So what is the basic difference between hydrogen and super absorbent polymers? So there is no much difference. It is also derived from the basic acrylic monomers. The basic differences with respect to water absorbing ability. When you take a super absorbent polymer, it can absorb 1,000 to 2,000 kilograms of water per gram of polymer. But such kind of hydrogel has the ability to absorb and retain a few hundred grams of water. That is the only difference. And such kind of hydrogels play a very significant role in various biomedical engineering sector, which include drug delivery system, tissue engineering as a scaffold for bone regeneration, and as wound dressing material to cure injured wounds. And also it is used for making contact lenses. And also it play a very significant role in the healthcare textile. And as highlighted, like it is also used in agriculture sector as the matrix for the control release of water and fertilizers and effluent treatment as well. Now I just want to go with healthcare textile, that is for the development of hygienic products. Normally we use the aged people, aged persons, they may not have that much mobility. They use a kind of absorbent material, like child. now how these type of materials, how these products are now, how this kind of products are developed. In fact, a class of applied polymer, there's going to be a polyacrylates. It is derived from the acrylic acid, which is polymerized through free radical polymerization, solution free radical polymerization mechanism. And such kind of polyacrylic, cross-linked polyacrylates are sandwiched between the two layers. One is permeable and another is the impermeable layer. Whenever it meet, water molecule or aqueous fluids like blood or urine, body fluids, they used to absorb and retain for a long time. And the beauty of this polymer is going to be, even under load, it cannot release the water just like anything. Okay, even very high load only it used to release the water or other aqueous liquids. Even the same polymer is used for making baby diapers also. Polyacrylates are used as adsorbent material in the baby diapers. Now this is going to be the swelling mechanism. So how it absorbs the water? So this is the a dry polymer. When this kind of dry polymer is introduced in the aqueous fluids like water or some other body fluids, it used to absorb the water through a swelling mechanism. Now what is swelling? So swelling is the process in which water molecule are trapped by the polymeric substance, because the polymer material will have a lot of hydrophilic groups like COH or NH2 or some other hydrophilic groups that used to absorb the water molecule, and these water molecules are get trapped inside of the vacant sites that are present in the polymeric network. And the major reason for the swelling process is going to be osmotic pressure based movable counter ions, and the change in the entropy during the change the network structure. So all will result in the absorption of water or aqueous liquids by the polymer material. And another one application of this hydrogel is going to be in the biomedical sector is development of contact lens. Since many decades we use spectacles to solve our vision problem, but some people they may not comfortable for this kind of spectacles. Now we know, due to this modern technique, we have a lot of modern tool, modern product for rectifying the vision problems, to rectify the vision problem. One among the usage of the hydrogel is going to be development of hydrogel. Development of contact lens using hydrogels. Now, how these lenses, contact lenses, are classified? In fact, basically, it is classified in two categories. One is silicon based, that is a earlier one. Now we have a polymer based one, that is going to be a hydrogel based contact lenses. Why we need to develop such kind of polymer based contact lens? Because the silicon based contact lens is capable enough to solve our problem as well. It will have more holes to penetrate oxygen very easily and keep our more hydrated, and also it will have good water permeability. But the thing is, such class of hydrogel cannot be used for dry eyes for prolonged time. So in order to solve this problem, people have developed another one class of contact lens that is based on hydrogels. So this is capable enough to keep our dry more hydrated, and this is more suitable for dry eyes also. So that is the advantage of polymer based contact lens, hydrogel based contact lens. And this is going to be the just a minute, I just want to have some water. Okay, fine. I hope I'm audible enough. The typical hydrogel material that are used for making contact lens is going to be one of the natural polymer, that is going to be a chitosan. It has a lot of functional groups. So this is the structure of chitosan. The modified chitosan is used for making such class of contact lens. And in fact, the mechanical property or the mechanical strength of this chitosan based polymer was enhanced by introducing this graphene oxide. And in order to improve the antibacterial, because since you are using this material in our eye, there is a chance for the bacterial contamination. So in order to avoid such kind of problems, there are some another class of materials also incorporated along the polymer while fabricating the material. There is going to be a silver nanomaterial, silver nanoparticles. So this composite hydrogel has the ability to solve a vision problem, as well it will prevent the bacterial growth on the particular eye. And in another case, it is also used to solve what it used to cure the eye disease also by loading the drugs on the polymer itself, because the polymer has the ability to act as a good drug carrier, and it used to observe the drug, and it will carry, and it will release the drug in the controlled fashion. I'll tell you what is the controlled fashion in the later slides, and this is one of the best example. And another one representative example for such class of hydrogen development is going to be using boric acid and polyhydroxyethyl methacrylate based super absorbent hydrogel. Normally we used to call it as a HEMA. Hydroxyethyl methacrylate is used as a monomer, and it will be polymerized and cross-linked through boric acid. And the ratio of boric acid in the polymeric material will modify its strength as well oxygen permeability, because that is also important while you're making contact lens. The lens must have sufficient oxygen permeability. So otherwise, your dry will face some problems. Your eye will face some problems. Okay, as I told you, the oxygen permeability can be enhanced by changing the boric acid concentration or the crosslinker. That is going to be the crosslinker. So when you modify that ratio, it will supply good amount of oxygen permeability. Right. And another one example of this hydrogel is going to be, as I told you in the beginning, this class of polymers are used as wound dressing materials. Normally, whenever we face such kind of problems, when any wound is happening on our any part of our body, we used to apply some medicines. So instead of that, if you use such class of an hydrogel, it has the ability to release the drugs, especially drug-loaded hydrogel will be used for such class of wound healing applications. And there are variety of materials are used for wound healing applications. These are going to be the representative polymeric material are used as material for wound healing applications like chitosan, alginate, cellulose, hyaluronic acid, dextran, gelatin, and these are all natural pre-polymer. And another synthetic polymer can also be used for such kind of wound healing applications. There is going to be polyethylene glycol, polylactic acid based polymers can also be used as a representative wound healing material. One such class of application is going to be a carboxylated cellulose based material. So this is one of the good material. I mean, in fact, it's a good representative material used for wound healing application. And the material itself, especially the chitosan material itself, will have a lot of antibacterial activities. So due to the presence of amino group in the polymeric structure, that itself will act as a good material to prohibit the growth of bacteria. Right. And another one application of this hydrogel in the biomedical sector is going to be a bone regeneration and cartilage repair. Now I just want to show you some representative polymer that are used for bone regeneration activity. So as I told you in the beginning, there are a lot of natural based polymers like alginate, chitosan based polymers are highly found suitable for making scaffolds to grow stem cells, and that will be injected or placed in the injured part of the body. So that will facilitate the growth of that injured cell in the very rapid manner. So one example is going to be a usage of alginate and chitosan based polymer, and the cross-linked polymer used for bone regeneration. So this is the place where we need to grow the cells in the rapid manner. So when you use such kind of hydrogel based substance, it will facilitate more growth. There are a lot of applications we can say, and another example is going to be a cartilage repair. again, natural based polymers are predominantly used for making wound healing or catalyzed repage material or bone regeneration material. And this was in fact this was reported by Zeebank et al. It's a kind of double network polymer. Just a this is one of the best example for catalytic repage. There is a kind of double network polymer. This is somewhat different from the simple hydrogels because it has two network structure. One monomer will be polymerized in presence of another free natural polymer. So that will give you another network, growth of another network in presence of another polymer. That is called double network structure. And another one example is going to be a kind of development of injectable type of polymers for cartilage and bone regeneration. Normally, we know that the stem cells collected from the body parts will be more useful, to treat a number of diseases. So such kind of cells can be extracted and it will be grown on the particular hydrogel derived from the natural polymer, modified natural polymer, and that will be injected into the place where defects are observed. So likewise, so this is the thing where I'm going to inject. So it will facilitate the growth of rapid growth of injured cells. It will rectify the problems very in the very rapid manner. Right, and another example of this class of hydrogen applied polymer is going to be drug delivery applications. Now, this is one of the important thing we need to understand. What is meant drug delivery? In fact, the release of drug in the internal part of our body. So depending upon the release and the release rate, we can classify the drug release into category. One is going to be a control release. So now what do you mean control release? Control release is the technique in which drug or active chemicals were made available to the particular specified target at a definite rate and duration, right? So at a definite rate and definite duration, this will be available in the particular part. That is called the control release of drugs inside of the body. And the second one is going to be a targeted drug delivery. It's a method of delivering drug or medication to a particular drug to the patient in a manner that increase the concentration of the drug in the part where the drug has to be originally released to bring pharmacological effects to that particular site and minimize adverse effect on the whole body. So instead of spreading the drug throughout the body, we are going to target only the particular site. That is called targeted drug delivery. So the developed polymer based on natural and synthetic polymer are predominantly used for such class of controlled release and targeted drug release techniques in the biomedical engineering sector. Now, this is one of the representative example. One such polymer used for drug delivery is going to be development of isoborane diisocyanate cross-linked with gelatin. So this is the gelatin and it is cross-linked with IDPI, that is isoborane diisocyanate, and it is used for development of antibacterial and anti-metabolic drug release like ampicillin and 5-fluorouracil. So these two drugs can be effectively released with the help of this synthesized naturally modified polymer. And this is the cartoon which tells you how the drug and polymer is getting interacted with each other. There are a lot of mechanisms involved in it. So that is what the polymer is used in the biomedical sector. Now I just want to link to this polymer for other miscellaneous applications. One is going to be a agriculture use. How this class of polymer can be used for agricultural application. So as I stated in the beginning itself, this class of super absorbent polymer has the ability to absorb and retain more than 7 kilograms of water. Even you have a single gram of polymer has the ability to retain 4 kilograms of water. It was reported in the literature. So that much ability it has. So such kind of ability is used for, it is used in the agriculture sector. So in fact, this is what the super absorbent polymer is getting swelled when it is placed in the aqueous medium or any aqueous liquid is introduced into the polymeric substance. Now, how to amend this super absorbent polymer is called the SAP amendment during cultivation practice, and why we need to introduce. So normally, due to increased population growth, we don't have that much amount of agricultural land, so we need to supply food for more than 130 crores. But we do have only limited land resources. So therefore, farmers normally feed various synthetic fertilizers like urea, potash, superphosphate fertilizers in the excess manner in the agriculture sector. And there are many farmers, they do not know how much amount of fertilizer has to be fed out. Due to the lack of that knowledge, they are feeding excess amount of fertilizer. So the excessive addition of fertilizer in the agriculture sector will result to various environmental problems like eutrophication, biomagnification, or other micronutrient imbalance based problems. So in order to solve such kind of problems, this polymer can be used as a candidate material to release fertilizer and drug in the controlled fashion. So during the cultivation process, as shown in the picture, when you feed this class of water soluble material along with like as stated as shown in the figure, along with the soil components. So while doing either in the rainfall or during irrigation process, it used to absorb a lot of water and it will retain as such, and based on the plant demand, it used to release the water in the controlled fashion. So as used in the biomedical application in the agriculture sector also, this class of super absorbent material are used as a matrix for the control release of water and fertilizers. So based on the plant demand, it used to discharge water and fertilizers at a controlled rate. Okay, so therefore, other environmental problems like eutrophication and other things can be minimized to some extent. And this is one of the representative example how it works. For example, peanut was cultivated. This one is SAP amended soil. This is going to be a without soil. That means during the cultivation itself, they added calculated amount of SAP in this side, and here there is no SAP at all. That's SAP amendment at all. So when you feed, when you do irrigation or any rainfall is occurs, it used to absorb and retain the moisture content, and it will release it depending upon the demand of the plant. But here there is no such kind of growth is absorbed because in both the field are cultivated only irrigated only once. So therefore, it is proved that the SAP amendment will help us to retain moisture content for prolonged time in the soil compartment. And what are the advantage of this SAP amendment in the soil? So as I stated in the beginning, so the SAP amendment in the soil compartment will provide a lot of benefits, which include it will minimize the runoff loss, and it will also minimize the soil erosion practice, and it will minimize the evaporation loss. And also, after its lifetime, it getting degraded. And if the polymers are made using sodium acrylates or polyacrylate, sodium acrylates or potassium acrylates or ammonia-based acrylates, so that itself will act as a fertilizer for the particular plant, and it will be consumed by the particular plant system. So these are the benefits of using SAP in the agriculture sectors as a controlled, as a matrix for the controlled release. Apart from this agriculture application, the hydrogels or SAP polymers can be used for effluent treatment applications. That means it is used due to the presence of various functional groups, polar groups present in the polymer structure. It has the ability to absorb or adsorb the various metal ions and the dye particles. As a result, it can be used for dye removal applications. See, this is the super absorbent polymer, and this is the dye solution, aqueous dye solution. So when introduce the polymer inside of the material, it used to swell, as well it used to absorb the colored matters, dye or pigment matter. And depending upon the polymer structure, we can reuse or we can throw it away. This is one of the another application for dye removal case. So these are the summary part. What are the area the SAPs can be utilized, like biomedical, agriculture, textile, and in civil structure also, and for making artificial snow, in communication system, coal and oil dewatering. So this is another one. So in case of oil crude oil. If more rocks, more water is present, so when you introduce such kind of super absorbent polymer hydrogel into the oil system, it used to absorb only water molecules, because this is a highly hydrophobic. It won't attract oil molecules. And another one is in electrical sector to provide more electric connectivity, and effluent treatment. So as I stated in the beginning, it is also used to remove metal ions. The first one was a dye removal concept, and another one is going to be a metal ion. The heavy metal ions like mercury, arsenic, antimony type of metals can be removed from the aqueous solutions. Because we all know what are the toxic effect of mercury and other heavy metals in the water body system. So by using this class of hydrogel polymer or super absorbent polymers, we can remove the dyes, dyes and colored matter or metal ions to greater extent. This is what the materials are absorbed. Say, for example, this is the metal ions, charged one and positive ions. It will be attracted by the negative compartment of the super absorbent polymer through either chelation mechanism or simple adsorption mechanism. There are different type of mechanism will be employed during this adsorption process. Depending upon the nature of pollutant and the nature of polymeric structure, different mechanism will be employed. Another one example of this hydrogel polymer is going to be in civil structure. How this is useful in the civil structure? Say, for example, during the construction of building, we used to apply more amount of water on the surface of the concrete to facilitate 100% curing, and for which sometimes we may use jute based material to retain moisture content to some extent. It's a old technique, but in recent days, people have developed a class of super absorbent polymer to provide sufficient water to the curing process of the concrete. Okay, so for this, what they did, so they used to feed the super absorbent during the concrete mixture itself, and it will be used during the curing process. Once you add water, it used to trap the water molecule. And like this is the one example. So this is the SAP particle. It used to observe the water molecule during the mixing, and when it made as a concrete, it will gradually release the water molecule depending upon the rate and at which the demand is occurred. Okay, so depending upon the demand, it will release the water gradually, and maybe once or twice water spray or water application sufficient enough to achieve 100% curing process. So therefore there are two benefits. One is we can save water, and it doesn't require any labor to perform that activity. So these are the benefits of super absorbent polymer in the other miscellaneous sectors. Still it has few more applications like cold dewatering, for making artificial snows, and in communication cable. So the cable should be completely free from moisture content. If there is any moisture is present, it will degrade the system. So in such cases, we may use the polymer, such class of hydrogel or polymer inside of the cable. So whenever is there any water molecule is present, it used to trap, and it will safeguard the electrical wires, or it will safeguard the system from the electrical shock. So these are the applications of super absorbent polymer and hydrogels. And in fact, I worked in two areas. One is control release of fertilizer and water in agriculture sector, and another one is going to be for effluent treatment applications. So with this, I just want to conclude my presentation. I thank the organizers for this opportunity. Thank you, one and all, for your patient listening. I'm ready to answer for your query if there is any queries are present.
Sir, thank you, sir. Thank you for your enlightening speech.
Thank you, Dr. Aral.
Dear participants, if you have any queries, kindly unmute yourself and ask the speaker directly or post in the chat box. Dear participants, please ask your questions by using the chat box.
The questions may not arise in two situations. If it's completely understood, then there won't be any question. If nothing is clear, there won't be any question.
If you are unable to unmute yourself, just raise your hand.
There are two persons have raised their hands.
Yes. Yes, Dr. Pankaj Kumar Singh.
Yes, thank you, sir. Myself, Dr. Pankaj Kumar Singh from IIT BHU. Your presentation was nice, sir.
Yeah, thank you, sir.
You have used SAP terminology, and another you have used the chitosome.
Yes, sir.
How this SAP particle is related to the chitosome?
Sir, when you use chitosan, you cannot make SAP because it is, there is a lot of problem associated with polymerization SAP material. I have prepared hydrogel using chitosan, modified chitosan. Acrylate chitosan I have used for making adsorbent material to absorb metallic substance from the aqueous medium. It is very difficult to get super absorbent polymer using chitosan. It will has its own solubility problem as well, swelling problem. If you use chitosan, solubility may not be up to the mark. Like
do you have gone through some nanoparticle study regarding this SAP particles?
No, sir. I didn't perform any nanoparticle studies on this chitosan.
Okay, thank you, sir.
Thank you. Thank you.
Thank you, sir. Sir, Dr. Is anybody?
And somebody was mentioning that Dr. Pankaj Kumar sir, cyclic voltammetry working. Yeah, that may be an application. There is another question. Is there any possibility to change the property of
Sir, one more question.
Is there any possibility to change the property of cement while we use super absorbent in cement? In fact, it won't affect the cement characteristics when you use super absorbent along with cement. It has the ability to absorb only water molecules. So during the process itself, we need to feed much of water that will absorb, and it will be retaining the water while we making concrete, and it will release it based on the demands. So it won't significantly affect cement characteristics. It may not alter the curing days or binding ability of the particular cement. The studies are there. In fact, I didn't put that slide. It was reported. It is literature. It won't affect cement characteristics. Well, that's like binding ability, durability. I mean curing ability, and durability as well.
Is any other questions from the participants?
Yes, sir. Dr. Suman, Department of Chemistry.
Yes, Dr. Usman is typing something.
Manoj from Bishop Heber College, can you convert polyethylene imine into valuable added product? Would you like to convert it into a water soluble material or something else, Dr. Manoj sir? Somebody, Pankaj Kumar Singh was asked my mail ID. Yes, sir, I just share it with you.
Dr. S. Ambika, do you want to tell anything?
Sir, what are the effects? Yeah, that's a very nice question. I forget to highlight this points. In fact, when you look at, as I told you in the beginning, SAP materials are synthesized from, hydrophilic monomers like acrylic monomer, vinyl monomers. So these vinyl monomers are highly toxic in nature. But when you polymerize it, that toxicity will be eliminated. There won't be any toxicity at all. It was a proved one because it is available in the monomer form. It will be very less in size, so therefore it can easily trapped by our human body cells. But it get polymerized, there will be in a bigger size, and the activity is getting reduced to minimum extent. As a result, the SAP particles may not, affect the food chain. Also, this is degradable in nature. So when SAPs or hydrogels are made using, biopolymer, they're biodegradable in nature, and also it has very good biocompatibility. So therefore, it won't affect the system at all.
Hello, sir. Good
Yes.
evening.
Yes,
Am I
sir.
audible?
Yeah, fine. Audible, sir.
Sir, I am Dr. Manoj Kumar from Bishop Heber College.
Yeah, sir.
So I raised the question, sir. So how we can convert that polyethylenimine? Because we are having some product in the polyethylenimine.
Okay.
So we want to convert that one into value-added product. For example, biodegradable plastic.
Oh, you want to convert that imine into a biodegradable plastics?
Yes, normally we can. So there is no functional group.
Okay.
And there is no heteroatom in the polyethylene.
Yeah, correct.
So then how we can convert that one into some biodegradable plastic, or maybe since we are from a chemistry background, so we want to convert that one into some sensor-based material.
Yeah, fine, sir. Fine, sir. So would you like to polymerize that alone, or you want to incorporate some other free polymer or monomers?
So normally we cannot convert that polyethylenimine, that product, into monomer. That's very difficult. Maybe we can add some material normally with that polyethylenimine product. So people will add some other material, and then they are making some trays and then plastic materials.
Yes, sir.
So we want to convert that one into the value added product. So maybe we can add some other material, or maybe we can do perform some reaction. Can we perform any reaction with that?
That is what I am asking you, sir. So if you want to convert it into valuable byproduct, the imines, right, sir?
Yes, yes.
Yeah, that can be added with some other material which are biodegradable in nature, or which is highly reactive with that particular material. So that when you polymerize it under such conditions, so it will be kind of byproduct with biodegradable in nature. So that we can achieve some polymer with biodegradable ability.
Okay.
Natural, you can try with some natural free polymers there. So a lot of natural free polymers are available. You try to react with that.
Okay, sir. Sir, can you post your mail ID in the chat box?
Sir, yeah, I already posted it, sir. Again, I will do it.
Okay, sir. Thank you so much.
Yeah, I have posted my mail ID twice a time. Please refer it, sir, and you can contact me at any point of time.
Okay, sir. Thank you so much.
Okay, sir. Dr. Arul, is there any question, or shall we?
Is there any other question?
Every hour is a grace, and now I feel gratitude in my heart to call upon Dr. C. Kavita to deliver the vote of thanks.
Good evening, all. Ma'am, am I audible?
Yes, ma'am, you are audible now.
Good evening. Sir, thank you very much for your informative and eye-catching presentation. Sir, really your presentation is very lively, which makes us travel inside the unseen concepts, which is microscopic concepts of chemistry. Thank you very much for that. In this technically advanced present scenario, energy storage is very important and even the hot field of research which needs more of innovations and enhancements. Hence, this presentation gives us a detailed insight into the basics of all types of batteries, starting from traditional to the futuristic lithium batteries. Thank you very much for that, sir. And further, being an expert in the field of polymers, especially hydrogels and superabsorbent polymers, your detailed explanation about the various applications in diversified fields such as medical, that is targeted drug delivery, superabsorbent polymers, lens, everything, which aids us in knowing the importance of these fields in the enhancing of our life. Thank you very much, sir. On the whole, it is a very informative session and it is a pleasure to have you as our expert of today's session of chemistry in the innovative technologies. Thank you, sir. Thank you very much.
Thank you, Dr. Kavita, ma'am.
Thank you, sir,
Thank you, Arul.
for your informative session.
Thank you. Thanks for the opportunity. And once again, I thank the organizers and participants for spending your valuable time. Thank you all.
Dear participant, a small announcement. So please